The next talk is by Shalom Carmel, and we're gonna start now. Our local time is 15:40, so let's get started. You got close to 1 hour.
Close to 1 hour, that's too long.
We can have some little Mickey Mouse jokes and fill it up if you want.
That's okay. I mean, I'm the one before last, so I guess people are tired and maybe bored and maybe sorry for coming anyway, coming to here at all. I hope not. Anyway, we're starting. Okay. Let's talk about 1 minute about legacy. What does legacy mean to us? Because legacy is a term that we hear all around whenever we speak about application information, life cycle management, and when we go and try to integrate existing infrastructure into new applications, we hear the word of legacy. And I think that the second definition sums it up pretty well. A legacy system is an existing computer system or application program which continues to be used because the user does not want to replace or redesign it. Now, obviously, if I just put something in, a new information system, I have a brand new ERP system, well, it's not a legacy yet. So sometimes at its life cycle, at some point of time, my application will become obsolete, or will be going to be obsolete. Or, you know, at least when I look at legacy systems, I can say that whatever is older than 3 years, it may very well be called already legacy because of the all the crud that and the entropy of the information that goes in. And of course, if it works, I replace it. So legacy systems pose a huge, may pose a problem to organizations because of the constantly changing landscape of technology. And I'm going to walk you through what happened to one such system and what lessons can be learned for the future from looking at this system. And this system is the IBM AS400. What happened here? What happened here? Okay, great. The AS400, now today called also I-Series or System I, is a mid-range platform that was released by IBM in 1988. So it's almost 20 years ago. It's a mid-range platform. You will find it in many places. It's very popular in certain countries, like in Italy. It has hundreds of thousands of customers all over the world. It's not compared in spread to Unix or to Windows servers, but you can count, you can be sure that wherever it is used, it is usually used to hold the crown jewels of the organization, okay? The financial data, the customer data, the logistics data, and it can be used, and it is used to run some of the most successful ERP systems that are around. So what do we have in this system right now, in this AS400 system? We have a built-in database, which is basically a flavor of DB2. We can write applications written in COBOL, in PL1, C, C++, Java, RPG. We have an object-oriented OS. I will get to it later on. Remember this object-oriented OS for a while. And you can, it is used by many organizations that already have invested a huge amount of money. Just to to give you the perspective, a AS400 that runs a business application has 500 gigabytes of disk space and has to support 300 connected users, will cost not less than $100,000. Okay, so it's a huge amount of money. It's a large investment. So I understand the organization that buys such a system, runs its application on it. You know, even if you take into account the fact that after 3 years, it's already its value is zero in the books. Still, I have it. Okay, the cost of placement is very high. I want to keep it. I want to continue to use it as long as I can, as long as it makes business sense to do it. This is on one hand. On the other hand, I have another problem. I have a problem because the landscape, everything is changing. Okay, I used to run a financial application on my AS400, so it worked pretty well. It was okay. Now, it's sometime in the life cycle of the application, we decided we need interfacing with other applications. Okay, so we did all kinds of batch jobs and FTP runs. Okay, we have integrated it, but now I need it to integrate online. Okay, we're speaking about all kinds of new ideas of integration. So this is a major it can be a major problem. In our case, I'm going to walk you through a couple of minutes to show you what happened. It's a bit of a history lesson, okay, so to speak. This system started out as a standalone server, standalone application. We had a manual-driven application. You can see it right here. We had a menu-driven application. You can see here on the right side an example of a screen, green screen. It was the system itself was connected to dumb terminals, to green screen terminals, with twin-ax cabling. At the outmost, we had the other servers connected via an SNA network. Okay, and it was all well. It was all well because I had application logic that was driving whatever the user could do, could interact with the system, okay? And the application logic was both masking the data from the user and providing a sandbox, even though in this example we can see that I have there are those lines right here. It's something that says selection or command. So theoretically, the user could run a command in this place, but I could restrict him. We could say this is a limited user, so whenever this user was writing a command such as call program X, he would receive a notification saying, I'm sorry, you're blocked, you can't do anything that is not on your menu. Okay? It was really great and it worked really well for a period of, for a couple of years until things started to change. Now, what changed is basically three major technological changes that happened not in the AS400 but in the environment. But they affected the system. The first one was the appearance of Windows, of personal computing. Second one was the understanding of IBM that they need to take some of functionality of Unix and put it inside this machine. And the third one was the appearance of TCP/IP and of Ethernet networking as the preferred method of corporate and of business networking. And what happened is that the old workstations, the old dumb terminals disappeared, the old SNA and twin-ax network disappeared, and what we have now, wherever, does anyone come here from an organization that uses AS400s? Anyone ever done anything with such a system? No? Okay. We have. Whereas a couple of years ago, up until the beginning of this century, you could still find terminals in some places, and in other places you had to buy specialized hardware to place it, to plug it into your PC and to connect it with specialized cabling. Today you can take just a regular PC, plug it into the network, open up a telnet client, and voila, you're connected. So, with personal computing, we don't have a dumb terminal any longer. We have a smart terminal that may run other code. It's not dedicated to this task. We have a new set of connectivity tools. If we had the sandbox in the beginning to start with, in which the user was limited to a control environment, now suddenly, because I have connectivity tools that were supplied by the vendor, by IBM, okay, to solve a business problem, I have suddenly bidirectional file transfer between those applications, between my database and the PC. Suddenly I can execute remote commands. I can run local commands on the PC, and the users got out of the application sandbox. Okay, if it were true, but there were no changes in the networking, then the problem would be, so to speak, controlled. Okay, I remember the days when, in order to communicate with the S400, I had to buy a special card, a Twinax supporting card, plug it into the motherboard, and someone who didn't have this kind of equipment couldn't connect to the server. Nowadays, it's not Twinax cabling anymore. Now everyone can connect. It's not SNA any longer, it's TCP/IP. And we see standard services ported over to the server. We started to see things that look trivial to you, that should exist on any server, but they were not trivial. FTP, Telnet, ODBC, RExec, all of these protocols, all of these are currently services that can run on an AS400, and some of them are very common, like FTP. Whereas, again, a couple of years ago, TCP/IP was an optional feature that you could install on an AS400, and you didn't have to install it. You could run it in your old Twinax or token ring service network. Today, you can't ignore, you can't use this kind of computer without TCP/IP. Again, whereas you needed special hardware and special software to connect, okay? You needed either a terminal and the card, or a specially written software to use this Twinax card. Today, a regular FTP client, a regular Telnet client is good enough for it. Now, one more thing that is complicates things even more is that when we were working with the applications, we were having login screens, we were logging into the application, we were logging into the server as operating system users. And imagine yourself this scenario. Imagine yourself that you have a web application. A web application is a really a good analogy, because we're talking about thin clients here, okay, basically. So imagine yourself that you have a web application and you are given a user and a password to use in this application, in the web application. This user and password can be used also to log in via FTP to the file system of the web server, and to log in with ODBC to the database, the transit. Okay, this is something that you wouldn't accept in a normal situation, but this is the situation with this system. Okay, once I have a valid user, a valid password, okay, to use it in my regular business application, I can use it also to connect via ODBC with standard drivers, or via FTP with the regular DOS client that I have. And I can execute programs via FTP. There's an extension. If you connect to an AS400 and you type quote RCMD and some command string, it will be executed on the server. So what we see is the attack surface grows and grows and grows and doesn't end yet. At some point, IBM saw that they needed to support TCP/IP and all kinds of services, and they decided to. They had a solution. Basically, the same hardware is shared between AIX and the AS400, the I series. It was called System I and I series and P series. So if we share the same hardware, we can maybe take some of the core of some of the AIX kernel, port it over to the AS400, use it to support TCP/IP, to support all the services, and this is exactly what they did. As a result, what we see is we have Unix compliant environments running on the AS400 and two different file systems, one which is the old legacy file system and another one which supports Unix, okay? So again, we'll see some applications of this in a moment. Well, we have two different Unix environments. One is called the Q shell. The Q shell is basically, it was rewritten specifically for OS400, for the operating system. It supports IPSIDIC. It's mandatory if you want to run any Java or any MQ, WebSphere MQ, which is a successful message brokering software. And there is something which is called PASE or PACE, and what it does, it supports binary supports of AIX programs. I can take any binary that was compiled on AIX on one platform, place it on a file system in a specific place on the AS400 and execute it on the AS400, okay? So on one hand, I can take something like OpenSSH, port it over, which is good. On the other hand, I can take Netcat and port it over, which is not very good, okay? And as I said, while Q shell is mandatory for Java and MQ, PACE is mandatory if you want to run things like SSH, if someone wants to write or create web applications on the AS400, they must basically install PACE in order to write web applications. We also have two file systems now. One is the root file system, which is just like any commonly known file system that you are familiar with. It supports a hierarchical folder system, and you can place in it, well, anything that you like. It can be text files, image files, JPEGs, Word documents, exe files, anything that you like. Of course, some of those programs that I spoke about that are compliant, fully compliant with AIX, also sit in this file system. And we have the qsys.lib file system, which is a subdirectory of the root file system and contains access to the original libraries, the original objects, all of the programs, files, data areas, and whatever exists inside the AS400 libraries. We can also move things between those file systems, okay? So if I take, for example, if I have what we call on the AS400 a save file, an equivalent of a tar file, an archive file, okay? We can today take it from the original library, copy it to the root file system, zip it, send it via email to another place, to another location, and then reverse the process and recreate those objects. So we don't need to have any special protocols or any special tools, just plain common file manipulation methods that we are all familiar with. Now, the combination of these advancements, of these changes, technological changes, that again, most of them are, well, all of them, they don't originate within this platform, but were external influences, created some really peculiar things. For example, if we take a look at what is a program on the AS400. Okay, it is, so to speak, object-oriented, in which I mean that we don't deal with files that I can copy and move around and manipulate on a binary basis when I speak about the objects. For example, I speak of things that are encapsulated. As far as I can see, if I look at a program that was compiled on the AS400, I can see an object of type PGM. It has a set of attributes, set of metadata that are specific to programs. There's a shared set of attributes between all objects. And a program is created usually either by compiling source code or by restoring it from an archive, okay? And therefore the paradigm is that a file is a file and a program is a program. In other words, if I look at the PC world or the Unix world, I can take an exe file. It was called x.exe. I rename it to x.jpg. And of course, it's not a JPEG file, but it masks itself to be something else. I can't do it on the AS400. Okay, I can't take a PGM object and tell it, now you will appear as if you are something else. It's something that can't be done. Or can it? To call a program, traditional program, we see do you see anything? Yes. I write a command, call, program name, parameters, and apparently all is well. Now, I did a mini poll among not a very large set of people who are developers, administrators, and experts of the system. I did it a couple of weeks ago, the beginning of November, and I asked them a question. Suppose, I asked them, that I have an AS400, okay? I remove the compiler, and I remove the ability to restore from an archive. Can I still create a new program on the AS400? Now, the question that I asked 12 people, I got 11 people who said, no, it's impossible. And another one who didn't want to commit to anything, because he knew that it was a catchy question. And of course, the answer is that it's not enough. The old restrictions are only relevant to the qsys.lib file system. So what's stopping me to upload the Java program and to execute it? Now, if you can see, if you look at here, to call a program on a regular program on the AS400, I do the call command. To execute a Java program, it's a different creature. It's a completely different creature. It's not an exe file. It's like comparing Java to exe, okay? They are different creatures. And what's more, so I don't have to compile it because I can transfer the bytecodes directly from my PC to the server. And I don't have to restore it into a library from a tape archive. I simply FTP the class file into the new root file system, and it's ready for execution. On my website, which you will be, I will refer to you later, you will see the address again. I show examples on how to execute AIX commands, okay? How to take, for example, a netcat, install it on the AS400 and create a reverse shell speaking to the server, or scan the entire network from the AS400. It's not a usual culprit, okay? It's not something that people are usually looking at. They think, okay, we have something we can run, we have to write in COBOL or in RPG to execute code. No, you don't have to. You have other venues of execution. So, how are we dealing with it? How is the industry dealing with it? Well, the industry is mostly looking where there's light, under the street light. They're not looking in the shadows. Now, what do I mean by that? we saw that we, for example, created a very large attack surface because of all of the connectivity. The new connectivity was added to this system. So what are people doing it? Basically, IBM has failed to address this and to provide proper tools for properly managing access, managing permissions to the system, but they did write exit programs, hooks, API hooks. They said, if you want to, you can write your own code, okay? So there is a small buzzing and energetic sub-industry of security, AS400 specific security, that provides all kinds of security tools. But the problem is that they can only manage whatever they have hooks to, okay? So not everything is hooks. If we look at the DB2 connectivity, I can connect to the AS400 from another server. I have two ways. One of them is via ODBC. This is, well, pretty much secured. But the second one is a protocol called DRDA. And ODBC is very well secured, so I can authenticate. I can intervene in the process of authentication and decide if this user can log in to use ODBC. Even though it's a valid user, I can decide that this user can't do it. But I can also track, audit, and see what this user does. But this is only for ODBC. DRDA, which is a standard way for different DB2s to connect to each other, talk to each other, is not covered. So nobody's addressing it, okay? Because IBM didn't provide the hooks. Another example that I'm going to show you right now is something which is even more interesting. We started in an environment in which we had dumb terminals, okay? So when I have a dumb terminal, it can only be used to connect to my system and to run whatever applications are written on the server. It only runs the terminal itself. When I have a PC, suddenly this PC is a general purpose machine, okay? So I can write, on one hand, I have one window which is open to a client that works with the AS400, and I will have another window that is open that contains Excel, okay, at both times. And gentlemen, we can abuse it, because apparently what IBM did is that they provided a command called start PC command. And what happens when I run this is that, I can show in demonstration, you know what? Best here. I can do several things. For example, if I select this menu, this is a live system, okay? If I type 1 says all the new furniture on eBay. Okay, now what happens is that I have a new browser window opening up. I'm sorry, this is a slow PC, but it will connect to eBay. And it's a great way to, for example, to create client-side integration. Okay, I want to send an Excel to a business user and to open it from inside the application menu. But I can do other things, other stuff. Okay, for example, no, not here. For example, if we look at the, okay, let me show you what happens when I run option 3 on the menu. First of all, we're going to look at the list of users that I have. Local users, okay, we see a set of users, of local users on my laptop. Now I return to the application and I type 3. Work with printed output. Okay, great. I work with printed output. Whoever was noticed it, there was something happened, something else happened, something flashed. If I go now to the user list and I refresh it, I can see that I have a new user. It's called Evil. Okay, it's a result of me running an application on the S400. It's a telnet, okay, it's a telnet, it's a goddamn telnet screen. I selected the... And of course, on the S400 itself, I am in the printed output. This is my printed output, whatever that means. Okay, let's suppose that I need to look at it, to release it or to view it. Some things that can be done about it. Okay, this is, I prepared an example in PowerPoint because I didn't know if I will have any network access. Okay, possible attacks on the client. This is a code example, a code sample that is, well, quite similar to what I ran with option 3. First one is I created a user locally on the PC. Well, maybe I can do other stuff as well. Okay, maybe I can download some backdoor to the PC and execute it later. Fortunately, we don't even have to run to execute, to install any third-party products because when I use, I said when, because it's not necessarily, not when, if I use the IBM supplied, what they call the client access suite, which is support for PC applications that want to connect to the S400, by default, I get something which is called the iSeries access for Windows remote command. Okay? It's optional, it's installed by default. It's also inactive by default. But what it does is provides an analytic daemon on the workstation. Now, all I have to do is run this. I can start the service, configure it to auto start, and add this switch, the NoSec switch, that basically says that I can connect, that now the PC runs an RExec daemon and doesn't require any authentication. It will run as the current user. And then I will run this command from somewhere else in the application, or from, not from the application, from my own terminal, okay, because I'm the evil programmer. Run remote command, any PC command, remote IP I can extract from the session, remote user none, remote password none, anything I want. I own the PC, the client. Okay, so we have an instance where because of having a remote smart client instead of dumb clients, we can abuse it. Okay, so what's next? With as far as legacy is concerned, well, I have here a list of 4 things that happen already. Smart appliances, smart coffee pots. Well, I know that the time will come when the coffee pot on the CO's table will order automatically new coffee capsules. It will be connected to the internet. It's not a threat, it's a security threat, possibly, but not related to legacy. Neither is smart clothes, smart homes, or even smart medical devices. So what is? I think that the next venue, the next thing that will affect the AS400 and a lot of legacy, because this is only a demonstration of legacy problems, is that venue in which there is a very large number of 3-letter and 4-letter acronyms, and where people are talking about it but don't know yet what it means. And this is the ESP, or the Enterprise Security Breach, Enterprise Service Bus, of course. But I think when I look at my experience in implementing ESB and SOA in large organizations, is the following. First of all, most legacy does not understand SOA, does not understand XML, does not understand ESB, does not understand web services. It's Chinese to most of legacies, okay? You can't expect a legacy system to work in the traditionally, the ideal SOA model, and that is to have its own SOA capabilities. It will never happen. Why would it never happen? Because of over-specialization. People, not only in legacy, but people everywhere, the developers don't know anything about security. Security people have never written a single line of code. Okay, system administrators have never written a single line of code. I work with system administrators who are really good guys. They know their work, but they don't understand how applications are written. And they don't understand how security can be implemented. So we have this over-specializations which leads to something that I call cluelessness. Okay, they don't know otherwise. When they don't know, and of course I'm not speaking about people who sit here, who we know, but the people who will be integrating legacy systems with the rest of the ESB, the rest of the SOA organization, will be people who don't really understand what needs to be done in order for it to work well and work securely. And the most important thing is that the business wants to make it work first and secure later. So all of security problems will be put aside, and we will have organizations which run ESB, run SOA as the main and business procedure, but with completely zero security. Any questions? Any remarks?
Doesn't look like it, so...
Okay.
Thanks for the talk. We'll continue in 10 minutes, and please give a nice applause to our speaker.